Hi, this is Aaron with Norse Engineering. Today I want to show you my Raspberry Pi Zero setup. I know that's like the cliche thing right now, but what I've done is part of my robot project to be able to build an autonomous robot hamster ball with some vision processing. Now this was several years before BB-8, but the concept is pretty much the same. What I want to do is put an image processing camera in the head of a BB-8-like ball. I don't want that to be heavy, as we've seen, and as I'll link in the description below, there have been plenty of people who have had issues with weight. So I'm not trying to add a ton of weight to that because that would cause problems. So batteries kind of are out, and traditional methods for power are out because they're heavy, they're bulky, and it's going to wreak a lot of havoc in the system. So what I've done is set up this proof of concept. I've got my Zero. I've got a version 1, the original camera module. It's hooked in. It's running on a 32 gig card. It's hooked up via my HDMI to this monitor. This monitor is plugged in down below my desk, and it's hooked up through an OTG cable to a powered USB hub, which has this keyboard and this mouse, excuse me, hooked into it. So I'll be able to have a keyboard and a mouse on my Pi. The Pi itself, for power, I'm powering off the 5-volt pin, and it's not the greatest way to do it. In the final version, in lieu of having things powered on the pins, I'll have it powered through the power USB connector that we've got right here. The Pi is, so right now the design is to put the Pi in as a blade, kind of like you see the Pi Zero server or cluster that people have built and designed. So they're hooked up. This is my power line, and the yellow is my ground. Yeah, the color convention is not exactly right. The rest of them are just hanging. This is a probe actually from my little logic analyzer that I got off of the Hackaday store. Anyway, so it comes into my breadboard, and it comes in, and it's being powered off my rail. This is my 5-volt rail right here. This is my receive. This is my receive coil. My transmit coil's on the bottom. Transmit circuit. Transmit circuit's powered by a 9-volt battery. That's powering this rail through the switch. And in addition to running the Pi, I have, just a very normal LED with a resistor to let me know that the power actually is being transmitted. Now these coils here, let's talk about these coils a little bit. These coils are insulated, so they can touch without being electrically connected. However, I'm not going to have them touch in this demo. And this is my transmit. This is my receiver. Transmit takes in the 9-volt power, and it modulates it. This is also modulated or tuned to that modulation. This demodulates it and makes 5 volts. I lost my 5-volt probe, so you're going to be able to watch me put it back in. These things are finicky at best, so I'm trying very hard not to knock anything. So there you go. That's coils. Let's put something in between it. Now it needs to be a non-ferrous material. So what I'm going to do is I'm going to take, I wish I had some Lexan, but I don't. So what I'm going to do is take some paper, because, ironically, there's not a ton of non-conductive stuff around in a lab. I pick this up, put it aside, and push this paper in between. Now, this paper is not very thick. It's maybe, 2 millimeters tops, 1.5 millimeters, something like that. And I push these two together. So the coils need to be lined up pretty close together, and I'm actually going to have to put some weight on that. something, again, non-fair, so I'll put the other half of the pad of paper on it. And they have to be lined up fairly well vertically so that one coil sits right on top of the other coil. Otherwise, the power transfer, you lose a lot of power transfer, and it's an inverse square law decay. So as you pull up and get them further apart, you get worse and worse and worse. So I'm going to power on the circuit. You can see the LED status blinking, and then you can see on the screen it's actually booting up. Now, originally I'd done another test where I took a picture, it worked just fine. However, I kind of screwed up some stuff in the video, got some stuff really messed up, so I'm reshooting this. That was actually the first time that I had ever taken a picture on wireless power. So you'll see the second time, but it works. And remember that the keyboard, the HDMI monitor, and the mouse are not going to use this wireless power. The power is solely running the camera and the Zero. So what I'm going to do is launch it into desktop. Press enter and start X. And we're going to takes a minute. Zero's not the fastest machine. We're going to take some pictures. Should probably do this. Oh, there we go. So we'll be taking a picture of here, some of my lab supplies. So let's go ahead and launch a terminal window. I'm going to type in, I'm going to CD first things first to my camera directory. This is where I keep all my pictures. So let's do an LS. You can see what's already in there. So you can see I have one image file, one video, and one wireless JPG. So let's RM that wireless, because we're going to use that same one. So it's gone. Perfect. So the command is ras pi still -o. We're going to call it wireless. You have to excuse my typing. I'm doing it with one finger. And I'm going to press enter. Oh, you can see me just a little bit in that preview. It's about to take the picture. Let's see. Looks like it caught my hand. I guess we'll see. So I do an ls again. Should show me the contents of this directory. Voila, we've got wireless. Let's go ahead and take it open it up and take a look at it. It's in the camera directory. Got wireless here. There you go. You had a picture of me filming you guys on my phone. So that's it. You can take a picture on wireless power. This means you don't have to have your Pi tethered to any power source. It means you could waterproof everything in your Pi and have wireless power transfer so that you could, say, dunk your Pi in your fish tank and take pictures underwater. You could do all sorts of things. It's really up to you. So good luck. I'll try to keep you guys posted on the status of how my robot goes, and in particular how well and robust that wireless head becomes. So keep hacking.